this. Okay, so this is another question for vectors, and over here you have been asked to find the position vector OB of point B. Okay, so since you have the position vector for A, and as I said in the previous question, you can best imagine using Cartesian plane that your origin is always here, and if you have a like -4 and +7, A point here, and then you want to move to B. So you're moving right 6 units in this direction, and then you are moving 3 units uh, down, right? So here it should be, B should be here, somewhere here, right? Okay, so now since you want this OB, so you can easily find it using this triangle right here. So by triangle law, you can easily find OA and then add to it AB. So OA and then added to AB will definitely give you your OB, right? You can't go to OB directly. You don't know the coordinates of B, no problem. But you can always find the coordinates of B using this vector addition, the triangle law, right? The triangle law, and you can see the triangle right in front of you. Okay, so this OB I can easily find using OA and then AB. So now for OA, I know 4, -4 and +7, and AB is also provided in the question. You can just add them, -4, +6, add up to +2, and +7 and -3 will add up to +4. Okay, for part B, you have to find the magnitude of the vector AB, and the magnitude here is represented by the modulus. So you can just simply use the formula for that, square root of the sum of the x coordinate and the y coordinates. So since we know the x coordinate is 6 squared, and there's the y coordinate is -3 squared, and will give you definitely something 36 plus 9, that should be 45, and the square root of 45, you can leave your answer here, or you can find it in the form of decimals, and that should give you 6.708, right? Okay, so or definitely to 3SF you should write 6.71. Okay, let's go to part C, and this particular part is here for 2 marks, and they're asking you to find the coordinates of C, given that the vector AB is 3 times the vector CB. Okay, the magnitudes, right? Okay, so what are we going to do? We know AB, so we are simply going to plug in it over here. In order to find CB, what should I do? I should divide, definitely. So 6 divided by 3 and -3 divided by 3. Why am I dividing? If you have any doubts, I am putting this 3 over there. So when it shifts to the other side, it goes on to divide the column vector. Okay, so now my CB comes out to be 2 and -1. Okay, that's not the answer yet, because you were asked to find the coordinates of C and not just the column vector of CB. Okay, so to find that, what are we going to do? Okay, we are going to use the coordinates of B. If we know, yeah, we know them. We know them right here in part A. We found them 2, 4. And I told you previously also in previous question that OB for the column vector is nothing but same as the B coordinate to the point B 2, 4, because in Cartesian plane, whenever we refer to any point, we always refer to it as a vector measured from O in the direction O to B, like this. So when this is 2, 4, so it means that in order to move to B from origin, you need to move 2 to the right, as you can see here, 2, and then move 4 units up. So that's right there at B. Okay, so in order to find CB, what am I going to do? Sorry, the coordinates of C. So since I know the coordinates of OA and OB, so what should I do? I should simply use this vector subtraction rule, that if my CB is this, so I should get my C using this vector subtraction, that OB less OC should be CB. Why am I saying that? Look at this. If I want to find, for example, if I have this B point here, and then I have C also, so I am moving from C to B like this. So if I want to find CB, what I can do is I can go from O to B and then less this OC, less this OC right here. I have this OC, but I can less it from this particular BC. So what I will get is that BC CB will be equals to CB will be equals to uh, BO, negative BO, and then this positive OC, right? So I can go easily to this, find this, and in order to find this, what I can do is, okay, so in order to find CB, I am having my OB as positive and my OC as negative. So my OB in the question was 2, 4, not in question but in answer to part A, and my OC can be easily represented by x comma y, since I don't know my C coordinates, and that is what I'm looking for. So I can assume it to be x comma y, right? So this, but what I do know here in this equation is the CB vector, that is 2 minus 1, and then I make a simple linear equation comparing the first row, so that would give me this. So I will have 2 equals 2 less negative x. X would come out to be 0 from here, right? So my x is 0, and my second equation will come from here. Okay, so for my second equation, I will have negative 1 equals 4 less y, and my y should be 4 plus 1, that should be 5. So that should be the answer to part C. Okay, the last part to this question, part D, it has two subparts for 3 and 1 marks respectively. Line L is parallel to AB. Okay, so whatever, and then it passes through this point, and find the equation of L. So to find the equation of any particular line, we are definitely going to use this standard form of straight line. But first thing, for line L, the gradient of line L is equals to the gradient of line AB. So what was the gradient of line AB? If you remember, AB was provided in the question 6 minus 6 negative 3. So since AB is a column vector of 6 negative 3, so I can easily find my gradient using this formula. And as I told you in previous video, this negative 3 represents the differences in the two y coordinates of A and B, and 6 is representing the the difference between the x coordinates of A and B. So I can simply put it here in the gradient formula, and I will get negative half. So that is the gradient for L as well, since it is parallel to the line AB. So the two gradients should be same. Remember, for parallel lines, the gradients are same, and in case of perpendicular lines, definitely you can recall the gradients, the product of the gradients is negative 1. Okay, now for this, we are going to put into the equation. So y equals to mx plus c. So this is y and this is x. So 5 equals negative half times negative 2 added to the y-intercept. Okay, so from here you will have positive 1, and your c will come out to be 4. And that's not over yet. You have to express in equation form, putting in the values of m and c, and keeping x and y intact. So this is your final answer for question number 7, part D, subpart 1. Okay. For the subpart 2 and the last part of this question, line M is perpendicular to line L. Okay, this is what we just discussed, that the gradient of line L times the gradient of line M should equal negative 1. That is the formula we use for two lines which are perpendicular, right? So out of these two, we know the gradient of line L right here. It was negative half. So you can put it here and find the gradient of this line M. So line M's gradient would be this, or you can simply say it should be positive 2. Okay, since this line passes through origin, so its C value should be 0. No need to put the C value, and that is the reason this question is worth just 1 mark as compared to the previous question of 3 marks. So you can simply put your y equals to mx. So m is 2 and x will remain x. So that's your final answer, and no need to find the value of c since the line passes through origin. And to help you recall, look at this graph. This particular line will definitely pass through the origin, this right here. And then when you put x1, so it has y2, so it passes through this. And then when you have x2, it has y as 4, so it passes like this. So definitely this line has y-intercept at 0, and c is nothing but the y-intercept. So no need to put points in order to find the value of C. That's not required. So that was it. 2 questions on vectors and a little bit a mixture of coordinate geometry in between. So never mind, it was a good practice. Hope it helps you out. Do consider liking and sharing the video and commenting on feedback. I always love feedback and intellectuals do that. So see you in the next video. Bye for now.